Right, cool. Good afternoon, everybody. I'm Phil Tetlow. I'm the CTO for Data Ecosystems at IBM in the UK, and I've got some really exciting things to share with you this afternoon. Just looking out into the audience, you look as if you've had a tough day already. So we'll try to make this as entertaining as possible, hopefully. A few caveats up front. Certainly one big caveat. This isn't my deck, but I am going to try to stick to theme, nevertheless. So let's get some participation going to start with. Let's talk about some buzz phrases, some buzz terms. So we're all here interested in, or anybody interested in IoT? Cool. If you're interested in IoT, I assume that you're interested in things like fast data. Hands in the air, let's get some movement. Right. So when we're talking about fast data, we're also talking about lots of data, right? Cool. Are we or are we not talking about big data? So anybody who's interested in big data? Excellent. Right. There are some other things going on in the industry that should be of relevance to you. So let's throw some more buzzwords in. Buzzword bingo. So if we're talking about AI, those who are interested in AI over the top of IoT or big data, so on and so forth. So more hands in the air, that's really cool. So we're talking about data analytics and AI at speed, typically talking to devices that are at the edge. Right. Given that the world around us is changing quickly, that presents a big challenge for guys like me and hopefully you. So how do you bring together all of that data at speed in a way that gives you acute insight, that provides the business edge and imbues AI and all the new technologies that are coming at us for a million reasons, in a million ways, from a million directions at a million times? That's really hard, yeah? Right. So what I'm going to do is I'm going to share a few things with you. I'm going to share a little bit about IBM's strategy in this space. I'm going to talk to you a little bit about how we have hardened around that strategy and the products, and in particular the technologies that we have brought together to help make the reality of uber high speed data and analytics a reality. So, reading from the slide, we're in a position where we need to get a lot of data through a system and pull off a lot of intelligence or a lot of analytics at the same time. So the way that we would have done this in the old world is we'd have brought together multiple different databases or technologies into a stack. That would have caused us a lot of time and a lot of effort. Putting together disparate technologies has never been easy. How do we get around that problem? So, let's move out slightly further and talk about things that hopefully are obvious to you. What this slide is trying to say is that data and analytics is becoming increasingly important. So a significant high percentage of the organizations that certainly I speak to on a daily basis, and if you look according to the analysts like Forrester, are now seeing data and analytics as being a significant driver inside their universe. What does IBM have to say on that? Right. So we have listened to the market and we have realized that there are one or two predominant drivers that are causing significant change in the industry. We know we're heading towards a world in which analytics and very, very highly complex, high-speed data architectures are going to become important. And we also know typically that at the top of that stack, we will need to be having conversations about artificial intelligence. In order to allow those conversations to take place, we have taken all of IBM's know-how and we have built a number of platforms over popular technology paradigms, excuse the buzzwords, I'll come back to those in a second, to ultimately allow us to get to the point where we can imbue artificial intelligence and very deep, very broad, very, very intense analytics over the top of multiple types of data and platforms, again, dealing with data coming from all directions at all times for all motives in all places. And the way we've done that is that we have built a ladder, or we talk about a ladder. So we have brought together a number of existing IBM technologies. You might be familiar with brands like Infosphere, for example, and we've built those on top of cloud-ready technologies, and again, I'll come back to that in a minute, to allow a capability that not only can you implement on cloud for data at speed in high volumes, but you can also implement it in a traditional way, in other words on-premise, or in a truly hybrid fashion. On top of that platform, we have built a number of, so this is where the corporate world of IBM tends to actually overpower me slightly, so we change our names very, very regularly. So we built a number of cartridges that are a collection of technologies that sit on top of a platform. And that platform is specifically intended to ease the way that you actually interact with your data. So here what you can see is what we've actually done is we've built an environment that works in terms of personas on top of project mentality, and within that project mentality we have split the act of dealing with data and analytics down into a number of phases. Here you can see those phases. So specifically we're talking about the act of collecting data, in other words getting data in your case it's at speed from a number of very, very disparate data sources at the edge. Then you've got to organize that data. So there are statistics in the industry that no doubt you will be familiar with. They certainly haunt my life. In other words, my guess is that most data professionals like you on a day-to-day basis will spend 80% of your time actually just manipulating your data into a position where you can actually do something meaningful with it. That's essentially what we're talking about here with the organized phase. On top of that, once you have got your data into position that you can do something meaningful with it, how do you actually get to that meaning? How do you get to that data value as quick as possible? That's what we refer to as the analyze stage. Then on top of that, how essentially do you use that as a springboard to get out into this whole new arena of interaction with intelligence? And typically what that means is how do you get out to your business advantage and ultimately your consumers and your users in a more amenable fashion. So today we're looking at technologies like chatbots, the list goes on. So essentially that's where AI enters the conversation. And as you can see on the right, essentially what we're talking about here is how do you do that in the modern world of cloud? Of course, we would like you to come and have the cloud conversation with IBM, but the technologies we are talking about here are neutral to the major cloud players. So the kit that I'm going to be talking about in a second is equally at home sitting on top of Microsoft Azure or AWS or Google Cloud, yada, yada, yada. Right, so the cloud platform, the hybrid cloud platform that we are talking about here, natively sits on top of, so you will have seen in the press this year that IBM we've just struck a major relationship. We actually bought them. We bought Red Hat. Yeah. And the reason that we did that was we were working really, really hard to produce a solution that was integrated, floor to ceiling, wall to wall. Now, when we are talking about that floor to ceiling integration and the integrity that's involved, and you cast that on top of the modern movements in our industry, such as the move to cloud and the need for agile technology, what you actually find is that through the history of certainly modern IT, what we've essentially seen is a route towards virtualization. So whereas we would have talked about virtualized machines maybe 2 or 3 years ago, now we've moved on to extremely lightweight, threaded type environments. And typically in the world that I live in, that's a conversation today about containers. And that was predominantly the reason why we spoke very, very closely with Red Hat. That was essentially to get a very strong operating system bond with a world that you may recognize as being so container-based universe. If we look at the common consensus around containers, today there are a number of projects or technologies that may or may not be familiar with to you. Essentially, IBM eventually had to take an opinionated stance as with regards to the direction of virtualized technology, cloud, data and analytics. That's why if you have a conversation with IBM about anything to do with data analytics, cloud, or the future of this whole data space, we will talk to you about Docker and Kubernetes. So the platform that we are talking about here is a containerized platform called Cloud Pak for Data That sits on top of an OpenShift platform, which is predominantly, again, about how do we get inside the container world, which lives on top of the Red Hat ecosystem, and then down into whatever infrastructure ultimately you're implementing on, be that in your own data centers, be that in a hybrid fashion, or be that on pure cloud, again, be that IBM, be that Azure, be that Google, be that whatever flavor you so wish. Now, inside that environment, what we've done is we have built in a number of capabilities specifically to look at very high speed data, very high speed analytics at very, very high volumes. And I actually can't see the slide clearly on the PC I've got in front of me, but hopefully up there you can see a technology called IBM DB2 Events Store. Have you got that? Right, so that's where I'm going to head next. And within, I'm just going to talk to that, forgive me. Right, so DB2 Events Store. So the idea was that what we wanted to do was take in modern community consensus around IoT technology and very, very high speed data ingestion and analytics, and bring that together with the best of IBM. So what we've actually done is we have produced an in-memory database with multiple levels of staggered cache, ultimately going down to whatever your native underlying disk infrastructure or storage infrastructure mechanism is. We have pushed that technology out to clusters now, so you'll notice some very, very big numbers on this slide. So earlier this year I used this technology for real with a Formula One client in the UK. At that time, they were talking to us about pulling sensor data off cars, not only while they were in race, but actually at the same time having a pool of cars going through the engineering process behind the scenes. When you look at that type of environment, you very, very quickly get up to many, many thousands of transactions or events per second. If you look at your average racing car, it has upwards of 250 sensors. They're spewing out data in real time at many, many thousands of cycles per second. If you put on top of that the fact that you have got two cars in a race, while at the same time you may have multiple cars that are actually going through modifications in the engineering process, due to very, very short notice modifications that have been brought in by the racing regulator, then you are very, very quickly up to multiple transactions per second. When we did the maths on that calculation up front, I was completely blown away. It was beyond my expectations. And what we found was that we were pushing upwards of 10 million transactions per second. There's a figure here on this slide which talks about 25 billion events per day. There's a slide later on where there's a mistake. They talk about 25 billion transactions per second. But if you actually do the maths on that 10 million transactions per second, it's actually greater than the total number of credit card transactions in flow around the planet at any one time. And what this particular racing team wanted to do was not only did they want to analyze the health of the vehicle as it was in a race situation, what they actually wanted to look at was their immediate competitive advantage. So there are some engineering characteristics built into race cars today that not only help that car specifically navigate to ultimately pole position within the race, but as it's doing that, what it's doing at the same time is, for example, trying to produce counter effects to stop the other cars in the race competing. So the dynamics on that vehicle actually produce interference to stop other cars actually maneuvering around it. Now, in real time, what the engineers wanted to see was how that data was not only affecting the performance of the car, but the performance of other cars and the immediate environment around it. That was a particularly intensive activity. So not only did we want to ingest data at extremely high speeds, but we wanted to do some ingestion. So first of all, we had to do transformation on the fly with that data. Then we had to do some temporal analytics on that data to actually make sure that it was coming in the right sequence at the right time for the right reasons. Then we needed to actually make sure that that data was fit for purpose before we actually fed it into a pipeline for downstream analytics. And that downstream analytics actually was phased. So we had immediate analytics in the moment, so we needed real-time response. So this is where we are. The car is burning It's burning hot, it's burning cold, these are the conditions of the critical sensors. This is actually what it means for the immediate operational circumstances of that race car. Then we needed to have second tier analytics, which were basically asking, what is this telling us about the immediate conditions? Do the engineers on the floor actually have to be thinking seconds or minutes in advance? And then beyond that, we were actually feeding the data, or we were aspiring to feed the data directly back to engineers back at the organization's head office, so they could be making second tier judgments not only about the engineering requirements in that moment, but what they actually meant for the engineering works that were going on at that time. So in practice, what they could be doing was working on their daily schedule to actually figure out how to get their immediate operational context fit for purpose, not only within the minute, but within the hour, within the day, within the month, and so on and so forth. That had to be a highly available environment, and we had to store the data and process it in a highly efficient manner. How did we do that? Well, we brought in some technology that we built inside IBM. Some of that was proprietary, some of it was built on open source. So actually under the covers for DB2 Events Store, ultimately what we're doing is writing down to Parquet. Is anybody in the audience familiar with Parquet? So Parquet is a technology that my understanding of the history is that ultimately came out of the universe that we would now recognize as being Kafka. Inside the open source, if it didn't come out of Kafka, it was certainly very, very tightly bonded to the emergence or the evolution of Kafka in the open source community. What we did with Parquet is we took the best of our database thinking. We actually produced a very tightly bound key value pair store that had multiple gates for writing down closer and closer. So in other words, moving further and further away from immediate memory down into persistent storage. Over the top of that, you can work with technologies like Spark. You can build agents, so Scala can talk to that technology directly. Of course, it's built in close liaison with Docker and Kubernetes. We've got direct integration with technologies like Hive, but on top of that, within the Cloud Pak family, so within this platform of technologies that we've built over this hybrid cloud aspiration, you can work with acceleration capabilities. So we have data schemas and architectures and analytical procedures pre-built. So we've got specific use cases around IoT that are already built. You can infuse those into your environment to accelerate your journey towards cloud. Lots and lots of good stuff going on. So as I've said, DB2 Events Store is ready for this journey to cloud experience. So it's built in. So I need to tell you a little bit more about our Cloud Pak type offering. So we're looking at a genuine platform play. So there's a term that I use when I go out to clients. We used to talk in IBM a lot about autonomics. So autonomics is the capability of machines and procedures to self-heal. So that was the capability of a piece of kit to place itself inside an environment, automatically figure out essentially what was going on with its immediate context, and allow it to self-heal. If it couldn't self-heal, that was the ability to essentially dial back to more authoritative capabilities directly inside the IBM family, so that we could help on-the-spot diagnosis to allow that system to get to the point of value more quickly. Right? So in other words, to maintain the value within inside the organization. The world around technology has changed. So if you look at the fact that now we are dealing with a predominantly open source type environment where multiple projects are springing up almost on a daily basis, for organizations like IBM and equally for you to predict the future with certainty and to actually strategize about where the industry is going to be or where a particular type of technology is going to be in 12 or 18 months is becoming increasingly hard. So the reason that we have moved towards a platform play is to try and provide as many capabilities as we can for organizations to allow you to evolve your technology and your solutions in the most optimum way. So there's some terms that we are starting to use inside IBM that I really love. They're not commonplace yet. The one I want to talk to you about for about 30 seconds is the idea of digital amniotics. Now, what I mean about digital amniotics is if you were to take just the seed of an idea and put some minimal capabilities in a single place to allow you to address a problem, so in your case, specifically out in the IoT or the very, very high-speed data world, how could you then easily pull in the additional capabilities that you may need to take that technology up to a higher level? That's what you see inside IBM's Cloud Pak Play, and specifically, that's what you see inside IBM's Cloud Pak for Data Play. So we have a number of very, very tried and tested capabilities inside there from the IBM heritage brands. So you'll see classical DB2 in there. You'll see a lot of our technologies for wrangling data from what used to be our data stage stable. You'll see capabilities for data governance. You'll see capabilities for data quality, and so on and so forth. Right at the heart of that capability, you will find DB2 Events Store. So just some words about Internet of Things. I'll let you read the slide. Essentially, Event Store is pre-built so it can quickly provision for new sensors. I'm reading the words off the chart, if you'll forgive me. Quickly action data coming from sensors. So again, what we're talking about here is an in-memory capability. When we have used, or when I have used Event Store personally in the past, I've used it in tandem with the technology called IBM Streams. So IBM Streams is the in-memory processing capability that we have been using for over 15 years. It came off the back of a military need coming out of the US. We were asked if we could process very, so ultra high levels of transactions in order to monitor the behavior of a very, very diverse, very, very active user community. We have been using that technology to monitor, for example, telephone conversations in real time with very, very big clients around the world. We've now moved that so that it's container friendly and lives on top of cloud. Streams is the technology, as you'll see on a slide in a second, that you can use alongside Event Store. So you can be taking streams of data from your IoT devices. You can be looking at their immediate context. You can not only be providing inline, in-stream analytics, but you can be applying analytical models, analytical AI models over the top of that analytics, and then ultimately you can be taking the output from that work and slowly passing it down, so eventually it remains persistent, again, on whatever data medium you have underlying your Parquet data stores or whatever data storage mechanisms you see fit. Right, so why are clients excited? So hopefully I've just gone over all of this type of stuff before. So there are some use cases that are hopefully obvious in this space. I'm not going to dwell on this slide. So we're talking about continuous processing, multiple varied data sources. That's actually really, really important because alongside DB2 Event Store, we now have got a technology that we're branding internally as being data virtualization. What that means is that you can access quite literally tens of thousands of disparate data stores around your organization. You can, without bringing that data, sorry I keep knocking the mic, without bringing that data to the center. So no longer do you need to be worried about classical data architectures such as enterprise data warehouses. Now you can generally stream data from edge devices, be they mobile phones, cash registers, you name it, you hum it, we'll play it, and again, process that data in real time. And if you want to talk to us about the real world clients that we have been deploying this technology with, please come and talk to me afterwards. I'm getting close to the half hour. I didn't think it would take that long. Right, some use cases. We have been talking to telcos about how you would analyze metadata coming off phone calls. I'm going to leave that with you. There's an interesting slide coming next. Hopefully there's some animation around this slide. So this is just to prove that we have built real-world architectures and we've done some deep thinking about how you might apply IBM's technologies in this space. What the slide is trying to tell you is that, and I can't read the slide again, right, so we can iteratively deploy analytical models. What this slide is primarily talking about is the use of a technology called IBM Streams. Behind it, again, you can use Event Store, and again, both of these are actually built into our Cloud Pak platform. So the intention behind this architecture was real-time customer analytics and stream time and the analytics of clickstream activity. And then the analysis of real-time content and campaign ingestion. For those who are familiar with telco, this should be a fairly familiar use case. Right, one more slide. So there are some use cases in finance. I'm not 100% sure whether I'm happy with this. So if we don't talk about it on this slide, we certainly do on the next. So real-time fraud detection is very, very hot inside finance. I'm certainly talking with big financial institutions about looking at the transactions that are coming off cash points and how we might interact with customers more intimately in real time and how they're then replaying that down onto their individual mobile apps. There's another architecture to talk about. So here you can see this was a very, very early prototypical architecture that we had in place for fraud detection. Some of the technologies here are being thinned down. Essentially, the technologies that we are talking about now is IBM Streams and Event Store at the middle of this architecture. And we're freely mixing that with open source technology. It depends on context. Come and talk to me about this. Come and talk to me after this presentation if you like. This is ultimately the slide I wanted to get to. It's probably best if you take a photograph of this. The point I'm trying to make here, lots of good technology because I'm running out of time. Phrased caching at various levels using various techniques, ultimately coming out of memory in a very, very consistent way, flushing down through various types of RAM, and then ultimately getting down into persistent disk, be that locally on machines or be that virtually distributed across a single cloud or multiple clouds. That's the way the world is heading at the moment. Okay, one other thing I want to talk about briefly. On top of Event Store, what we've actually done is we've taken 50 years worth of query heritage that we had built into the DB2 brand. If you don't know the history behind DB2 and SQL, essentially we were the guys who got there first. We worked alongside the ANSI committees when SQL was born. What we've done is we've modernized SQL so that it can now talk to multiple different data stores and multiple different technologies out in this open source world. What you will find is that the DB2 Common SQL engine, I'll leave you to read the words here, is built into the core of DB2 Events Store. What that means is you can inquire of your data in real time, and you can acquire over your analytics using close to standard SQL. I think that's pretty cool. That's helped us in truly, truly complex environments where we've got data that's been spinning around the universe, not only in real time, but we've had to throw some really ugly, highly latent queries over the back of that technology, and support that actually manages to bring together an amalgam of intelligence that's truly powerful. And then, ultimately I'm getting to the punchline. So what are the key takeaways? So Cloud Pak for Data is one solution for all your data needs. Again, think about this fact that we're moving to a world where we're dealing with complex analytics and AI. How do you do that? IBM is trying to help by bringing together multiple tiers of capability, specifically in the data arena, and with DB2 Event Store and IBM Streams, we're pointing specifically at the markets for IoT and real-time data ingestion and analytics. As part of that, you can perform data and AI analytics in real time, and DB2 Event Store is the backbone of all that capability. I've said lots and lots over the past half an hour. There are a million billion thoughts going around in my head. Hopefully you've got 1,000 questions for me. I'm Phil Tetlow. I'm here on Thursdays. It was very, very nice to meet you. Enjoy the remainder of the day, and I'll be on the IBM stand, if not here after this event. Lovely to meet you all. Thank you very much.